Good morning to Algebra Honor students. Welcome to our day 6. Today we're looking at adding together the different numbers in a geometric sequence. Remember, if I'm doing a sum, a fancy name for that is a series, so we're going to be using that word. Now before we do that stuff, let's look at a couple math memes of the day. This is that classic problem that you always see when you're doing word problems, and there's a man in a store and he's buying 40 watermelons, and you think to yourself, Miss Goldenberg, that never happens in real life. Here is some proof otherwise. I also have a second one. This one's like really crazy, where we found the guy from the math problems. Look at that. They have filled their entire car. I have no clue what one would want with this many watermelons. Maybe they're having like a watermelon eating contest or a watermelon themed party, who knows? So for our warm-up, I've got an explicit formula for a geometric sequence right here. I want you to tell me what is the sum of the first 6 terms. Okay, so do this for your warm-up. You're going to pause the video, work it out, unpause, and check your work. Okay, so here is my work for terms 1 through 6. Notice I tried to color code it oh so beautifully, and I only really showed my work for the first couple. After the first couple, rather than using the formula, I just used the logic that every time you continue to multiply by 3 to go from one term to the subsequent term. And that's kind of a little bit more of a recursive idea to think about, that it's previous term times 3. Right, like a sub n plus 1, your next term equals a sub n, your previous term, but times 3. And that's really at the root of what this is. So this would be a recursive definition rather than your explicit formula. So here's your explicit formula, and then here is your recursive formula. And something to keep in mind is that by the time you get to the test, you'll want to know both ways to write it out, but I generally let you kind of choose whichever way you want. Oftentimes I'll say, write it either explicitly or recursively, but once in a while I will ask you a question where I say, can you take this recursive pattern and figure out what the explicit rule would be. So sometimes you'll have to go back and forth. And here's my answer at the bottom. If you look down here, I added them all together. Okay, so let's move on. What we're going to be talking about today is there a nicer way to do this? Right? Is there a shortcut similar to last time when we did our arithmetic series, a sum? We were able to find a nice shortcut. This one is not quite as easy to remember. And in order to figure out what the general rule is, our formula, we're going to be doing a proof. Okay, so you can either follow along and just watch, or you can write it out and go step by step if you'd prefer. Whichever way you think will help you go through all the steps best. So what I've got here is just a general look of what a sum will look like. And what this is saying is, the sum of n numbers, there's your first term, right? And then to get to your next term, you do times the ratio. And that's why it's a1 times r. And then to get to your next one, you do times r again. So there's 2 r's. Now, the reason why this one ends with r to the power of n minus 1, rather than, why is it not a1 times r to the nth power? Remember, if we are assuming that there are n terms that I'm adding together, right, let's think of a really concrete, easy example. Like maybe my rule starts with a 5, and I do 5 times 2, plus 5 times 2 squared, plus 5 times 2 cubed, plus 5 times 2 to the 4th. Let's say that's my total terms, right? So I've got 1, 2, 3, 4, 5 terms. Notice the reason why it's not to the power of 5 at the end, but to the 4th power, is because I don't start doing times my ratio until my second term. So that's why it's not to the power of n. And then one way to think about why we are looking like this, right, is because if you go to a previous term, the power goes down by 1. So 4 minus 1 gets you to the third power. Similarly, if you kind of think through it like n minus 1, 1 lower would get you to n minus 2. It's a little harder to see that concept. So I'm going to erase this just so I can have a clean space. So this is going to be our first equation. Our second equation is going to be equation 1, but times r on both sides of the equation. And it's that same r, that same common ratio. So I'm going to write it out. So it's going to be r times s to the nth power, times s sub n, your sum of the n terms. And then I'm going to have a1 times r plus a1. Now remember, this one used to be r, so r times r is r squared. So notice your powers are going up by 1 each time, r cubed plus dot dot dot. Now these two are a little trickier. What I would think about is r to the n minus 2 times r to the first. You want to add your exponents. So then you have r to the n, negative 2 plus 1 is still negative, but just a negative 1. So it's going to be to the r to the n minus 1. Similarly, r to the n minus 1 times r to the first power. The 1s are going to cancel out when you add them. So it will just be a1 times r to the nth power. Okay, so there's my equation 1 and there's my equation 2. Now notice equation 2 has been done by multiplying both sides by the same thing, which is completely correct mathematically, right? So my next step is I'm going to do equation 1 minus equation 2. So right here we're doing 1 minus 2. And I'll try and maybe do that in pink just so you can see. So I'm doing my subtraction of these two. Now when I subtract them, something kind of interesting happens. Now if you kind of go by the equal sign, right, you've got s sub n minus r times s sub n. That one's not so different. But here's what's kind of interesting. When I look, if I'm doing the top row, take away the bottom row, you're going to notice that some things are matching. Like a sub 1 times r is here and here. Those are going to cancel out when we subtract. Same thing's happening here. Those are going to cancel. Remember your next one with the dot dot dot, this one would be with the cubed power of r. And then let's see. We have some other stuff going on, right? We've got the n minus 1s. You can assume that because n minus 2 is 1 before, it would be somewhere in the dot dot dot. So it looks like the only two things that remain on that side are this. And remember, since we're subtracting, it will be a sub 1 minus a sub 1 times r to the nth power. So we're kind of getting to a place where we can kind of start seeing what the formula will be. Now think about the fact that we want the sum s sub n equals. So I want to have one of those, and I'm looking at my left side and I've got 2. So let's factor that out as greatest common factor. So s sub n times what is s sub n? We'll put a 1. And then minus r. Remember, if you were to redistribute, you'd get back to where we started. Okay, I want to do the same kind of thing on the right side. I see a sub 1 in both of my terms, so let's factor that out. A sub 1 times 1 is a sub 1, and then minus r to the nth power. And we are almost home free. Okay, I'll make a little note here. Factor out our GCF. One thing that you'll probably have trouble with is that 1. Think about that as it's the coefficient, like 1 times that, 1 times that. A lot of people do have trouble seeing that 1 though. It's just kind of like an interesting thing. Sometimes people don't put anything all together, but remember, if you start with 2 terms, you want to still have 2 terms in the parentheses at the end. So now I want to solve for s sub n, right? So if I'm solving, I'm going to divide by my piece that it's being multiplied by, which means I have to divide by that on both sides. So here we're solving for sum of n terms. So our final answer is going to be that the sum of n terms is your first term times 1 minus r to the nth power all over 1 minus r. And all those are coming from A1 equals your first term, right? N terms total. R equals your ratio that you're multiplying by. So all of those are really coming from your general, or excuse me, not arithmetic, your general geometric sequence, right? Those are the same terms that you use throughout. So this is our rule. Now, notice you wouldn't want to have a ratio that was equal to 1. That would make this be undefined with the bottom, right? So what we're going to do is we're going to try and practice this formula and practice getting used to it. I will be posting a formula sheet that includes this formula as well as your arithmetic formulas. So it will include both formulas for each arithmetic, geometric. It will have sequence and series. So let's look at a couple practice ones. So this first one says, let's go back to our warm-up, right? We've now got a more efficient way to do this. So I want to plug in everything into my handy-dandy formula. And this one, like I said, is kind of a little harder to remember. It's not as intuitive as your arithmetic one. So the sum of the first 6 terms, I'm going to put the total terms at the bottom. My first term is a 20, right? You start with 20 and then you start multiplying by 3. 1 minus my ratio is 3. The nth power, that's how many terms. That's going to be 6. Right, and if it kind of helps, you can highlight where that's coming from, where the n is coming from. There we go, where the a sub 1 is coming from. Sometimes people like seeing kind of those color codings to help. And then it's all going to be over 1 minus your common ratio of 3. Okay. Oh, oops, I totally color coded that wrong. The yellow should be 6 terms, and your ratio is 3. So let's get our ratio as pink. There we go. That's better. That's normally when someone would have called it out during class, and I would have had an actual person to interact with, rather than just myself. Miss you guys. Miss seeing you guys every day. So I've plugged them all in. Now, this is the part where you have to be a little bit careful with your order of operations. Okay, so 20 times, and I'm going to pause and pull up my calculator. Okay, so I'm just going to show you what I would normally do when I'm typing it in. I would normally start inside the parentheses. I would do 3 to the power of 6, and then I want to do 1 minus that number. So 1 minus second, and so remember that's a little negative sign. And then I want to do that times 20. So I'm just kind of starting inside with the parentheses and going bit by bit. And then I have that times 20, and then I need to divide by 1 minus 3 is going to be a negative 2. So 7280. I'm just going to write my answer out here to be easier. Okay, so you really want to be careful with your order of operations for these kind of problems. I've got a couple more just for practice. This will be some good practice looking at sigma notation. Remember, this is where you start, this is where you end, and then this is your rule. And you want to be careful. Sometimes it's not written in our explicit formula, but this is written just like your geometric rule, right? A sub 1 times ratio to the n minus 1 power. If it's not to the n minus 1 power, sometimes it's written like that to trick you up a little bit, and you have to be careful because your first term is not necessarily the first number that you see there. So we're going to write out our formula. So if I look back at my sheet, right? My sum of n terms equals first term times 1 minus the ratio to the nth power, all over 1 minus the ratio, right? Feel free to look back if you need to, and feel free to print out that formula sheet. Okay, so I'm going to pause the video. I want you to try the first one on your own. The second one is a little bit trickier, so we might need to talk about that in a part 2 video because I'm running out of my end time on my video recorder. Okay, there is your answer for that problem. And what I'm going to do is I'm going to, in the second video, go over part B, because this one is a little bit trickier to think about. The reason why it's a little harder is because of your increments. They're not 1 through a number like we had for the first one, 1 through 5. So take a look at video 2 to walk through this problem.